Hello everyone and good morning to all of you. Today we have problem which name is maximum element after decreasing and rearranging. Leetcode 1846 problem. So before going forward in this video, please make sure that you have liked and subscribed to this channel. And also it's my advice to all of you that please read the problem and try to build up the intuition in your mind and try to do the code. So if you are beginner, then you will stuck at some point definitely. Then see this video; it will be beneficial for you. If you simply see this video and do the code, will not be very much effective for you. Okay. So let's read the problem. Problem is saying that we have given an array which have positive integers. Perform some operations, possibly none, on ARR so that it satisfies these conditions. These are some conditions that first element should be 1. Okay, must be 1. Okay. The absolute difference between the two adjacent elements should be less than equals to 1, and I is going from 1 to ARR dot length. Okay, these are two conditions, and they are two operations that we can perform. First operation is decrease the value of any element of ARR to a smaller positive element. So it means that we can decrease a value like the first element is 1, so we can the first element is like 3, so we can decrease the value up to 2, means previous value से कम होना चाहिए और we can rearrange the element of ARR. Okay, this is done. Return the maximum possible value of element of ARR after performing the operation of satisfy the condition. So let's see the example. So in this first example, we can rearrange the element because the given condition is the first element must be 1. So we can rearrange it. So it will be 1 2 2 2 1. 1 2 2 2 1, and the maximum element, and we can see the absolute difference between the two elements is less than equals to 1. So this is the perfect array, and we have to find the maximum difference between the maximum value. So maximum value will be 2. So let's see the intuition and approach part for this, that so that you will understand better. So as you can see, these are two conditions. AR0 must be 1, and the absolute difference between the two array elements should be less than equal to 1. So we have example 100, 1 and 1000. So we can sort it. So if we sort it, then it will be 100 and 1000. And now we can see our first condition is fulfilled, but our second condition is the difference between the two adjacent elements should be less than equals to 1. So we have to decrease this 100. So we can decrease this up to 2, so that 2 minus 1 is less than equals to 1. Our second condition is satisfied. And also this will be 3. So that 3 minus 2 is less than equals to 1. So second condition is also satisfied. So our final array will be 1, 2 and 3. So now we can find the maximum element in this array, that will be 3. So this is our answer. If we solve it, further solve it, so this will be AR of I is less than equals to 1 plus AR of I minus 1. This is the good condition for the array. But we have to find the, this is the good condition, so that we will we will do nothing in this condition. But if the condition is AR of I greater than 1 plus AR of I minus 1, it means the condition is opposing the given condition. So for in that condition, we have to perform some task. So let's do the code so that we can understand proper. So let's open this. Now firstly what I will do, firstly we will sort it so that the first element should be 1. Okay, like if you can see, this is the given array. If we sort it, then it will be 1 1 2 2 2. So the first element will be 1. So let's sort it. Sort of ARR dot begin comma ARR dot end. Done. Now what we will do, we'll check if first element is 1 or not. If first element AR of 0 is not equals to 1, in that condition what I will do, I will decrease the element and do and make it AR of 0 equals to 1. Okay, this is done. Now what I'll do, I will apply a loop. As you can see, the I is going from 1 to length, uh, length arr dot length. So why we are starting from 1? It is a 0 index because AR of 0 we have already defined. Okay, so AR of 0 equals to 1. So now we will apply a loop for int I equals to 1 to I less than ARR dot size, then I plus plus. And now in this we will check the condition. If this is a given condition for us, that is a good condition for the given array. But we will take opposite of this. AR of I is greater than 1 plus AR of I minus 1. We will check this. If ARR of I is greater than 1 plus AR of I minus 1. In this condition, what I will do? In that example, what I have done is I have taken the second element is previous element plus 1. So AR of I equals to AR of I minus 1 plus 1. So that the absolute difference between the two adjacent elements will be less than equals to 1. So let's do this. AR of I equals to 1 plus AR of I minus 1. As you can see, now this condition is given AR of I minus AR of I minus 1 equals to 1. That is the perfect condition for a good array. That's why we have done this. Now, this is the fulfilled condition. Now, what we have to return? Return final element because we have sorted. So, this now our array is sorted. So, what I will do? I will do I will take the last element because that will be the maximum element for our array. So ARR of ARR dot size minus 1. Let's run this code. It is working perfect. Let's submit this. As you can see, it is working perfect. And let's discuss about the time and space complexity. As you can see, we are only doing the sorting approach. Okay, so the time complexity will be n log n basically. So and we are not taking any space, so space complexity will be go of 1. We are not taking any external space. This space is given for us, a vector of AR, vector of int ARR. So this space is given, so we are not taking any external space. That's why our space complexity will be go of 1. So this is the full solution for this. And if you know another approach for this, then please comment. And if you find this helpful, then please like, share, and subscribe. Okay.